actually
Do we
look.
have attendees?
What?
Did anyone come?
We had like, yeah, we have one person, but we actually had a lot more people signed up. But I don't know what's going on. Could you help me look at the screen so I can tell me left or right?
I think that's good.
Yeah.
Then
Let me know when there's less wall.
you know how to.
Yes. But first, you need to connect something to something. That is not connected. You want to connect it to something? Yes.
And where should this be?
To something that.
No, I mean my computer.
Oh,
goes
then
there.
it should be connected to there.
No signal.
Eventually, you switch to.
Okay, now I see it there. Cool. Can we wait a few minutes? Just take like 5 minutes late. I need to drink some water. You tell me. You tell me. It's weird that nobody can. It usually is one or two people. But no one external. Yeah, Okay. Are we live? We're live? Okay. Hello. Welcome. So today I'm gonna talk about using OpenVINO with some of the new hype, which is LLM. So first of all, this is a workshop sponsored by the fine folks at Intel, specifically the team at OpenVINO. If you don't know about OpenVINO, OpenVINO is a toolkit that allows you to run inference on any hardware device, albeit Intel devices like CPUs, GPUs, FPGAs, and even an embedded NPU that's called Mobius or neural compute stick. This is in total, this would be like the 6th workshop. For Q2 of 2023, this is actually the 2nd workshop. If this is the first time that you attend one of these workshops, don't worry. It's not scary, it's not super advanced. And the goal is for you as a developer to dip your toes into machine learning and specifically get to know this awesome tool that is OpenVINO, that can make your life easier and can make your wallet happier once you're loading credits. And I say that because running machine learning models in production is expensive. But if you have a very optimized model and you can run it on less sophisticated hardware, then you will be paying less for your infrastructure to serving your clients. So that's why I love OpenVINO. I use it in production. I didn't introduce myself. I'm sorry. My name is Jose Ruiz. Everybody calls me Chepe, and particularly here at Hacker Dojo, everybody calls me Chepetronics. So what do I do? I am an electrical engineer by trade. I've been developing software for the past 19 years or so. Started in embedded systems, and little by little I moved towards cloud and specialized in AI. I've been working with machine learning since the past maybe 6 or 7 years. And right now I'm working with a company called Picaio that basically what we do is we apply AI and machine learning to financial documents to accelerate financial processes in large enterprises. If you want to know more, ping me. And if you want to know more about the topics that we're going to be discussing today, please join the Discord. I'll be publishing the link to the Discord a little bit later today. So today is going to be a hands-on workshop. You can follow along if you want. I'm going to ask Victor to write a URL for me in a few seconds so that you can, if you are in the local network connected to the Python wireless network, then you will be able to join and follow along from your computer. We'll be working with 2 notebooks. And you can basically replicate what I do. So today I'm going to be showing one of the latest examples that Intel uploaded to the repo. I'm going to be showing you some of the tech that makes up this particular notebook, what you need, the basics that you would need to know to understand what's happening under the surface. And I'm going to show you a couple of very useful repositories that you could use later. So the first one is going to be the one that I show every workshop, which is the Github repo for OpenVINO notebooks. So OpenVINO has 3 or 4 repositories, One of them is particularly useful, which is this OpenVINO notebooks. If you go here, you will find several notebooks organized by categories. And what are those categories? Well, you can see here in the README. First of all, we have a lot of examples, and some of these examples are using the most exciting and new models that have been released in the past months or weeks, even, including YOLO V8, Segment Anything, Stable Diffusion V2, generating videos from prompt, Whisper, Clip, etc., and the one that I'll be showing off today, which is Dolly V2. Now, Dolly V2 is a large language model, and it's, to my knowledge, the first large language model of this dimension with a completely permissive commercial license. Who is familiar with the term large language model? Who knows what that means? Okay. So large language model is something that's on the news every day, and basically what it refers to are models that can take text as an input and provide text as an output. These models are based on something called transformer, which is a set of layers that allows the model to learn the meaning of the text that we are inputting. So there are mainly two parts of a transformer-based model that we need for it to work. One is the model itself, and the other one is the tokenizer. Okay, and the tokenizer is an algorithm that will allow us to split our text into shorter tokens that could be words if they are common, or could be parts of words if they are tokens that belong to a word that's not common, or an iteration of a verb or a conjugation of a verb that is not as common. So that's called the tokenizer. And in order to use a model, a large language model, what normally happens is we run a pipeline that is basically a chain of inferences where we input the text, we convert that text into an array of tokens, and then we send those tokens to the model, and then the model starts generating a sequence. So I'm going to show you today how we can do that with Dolly V2 with its specific tokenizer, and we're going to be leveraging an awesome library, hub, resource. It's many things and everything at once that is called Hugging Face. So Hugging Face today is, I would say, where you should go to search for a model that would be available for you. There are many models with many licenses that you can go and explore, and we're going to be leveraging a couple of libraries that come from Hugging Face. One of them is called the Transformers library. So, as I mentioned, the transformer is the name of a layer that transforms an input sequence into an output sequence. And in that process, it understands the meaning of that input sequence. Hugging Face provides an amazing library called Transformers that provides an abstraction layer that is agnostic of the framework below. It works with PyTorch, TensorFlow, and JAX. And it allows you to train models, export models, train models in one framework, exports models in a different frameworks. And in particular, we're going to be using that to load our pre-trained PyTorch weights into OpenVINO, and then compile that into OpenVINO, which is what we're going to be using for inference. And then we're going to be using that OpenVINO optimized model to generate text using Dolly V2. The other library that we're going to be using is an extension called Optimum. So Optimum provides a set of extensions to leverage accelerators that might be available on your particular hardware. There are several of them. The one that we're going to be using today is the one that belongs to Intel, which is Optimum Intel. And it uses basically two of the main components of Intel's set of machine learning resources. One of them is the interneural compressor, which basically what it does is it shrinks your model and makes it run faster than what it was in the shape it had when you trained it. And the other one is OpenVINO, which I just explained, is this toolkit that allows you to run inference on multiple hardware devices without you having to do anything special. And I'm going to show you how you can run these devices. The very same model deployed to two different devices, and you're going to see a difference in performance right now. So, without further ado, what else I want to show you is, yes, that. If you want to know a little bit more about the model that we will be using too, we're going to be running inference on the 3 billion parameters variant of the model. So most large language models are trained on a very large model, and then they are shrinked to use fewer parameters. And they, depending on the fine-tuning that you perform over those models, you can get pretty decent performance, especially if you specialize in a task and perform some fine-tuning or training on your own data. So to this point, do you have any questions? No, great, excellent. Please interrupt me if I'm going too fast, if I'm going too slow, if you don't understand what I'm talking about and you want me to go back and say, what are we actually doing? So again, this is, I'm going to start with this. Is that readable? Is that too small? Is that good? Okay. I'm going to start with the OpenVINO examples, number 240, instruction following Databricks Dolly. You can read about more about that model in their repo, which is this. And you can see how it works, what limitations are known, what risks you might have, and all about that model. I'm not gonna waste any more time about that. The important part that I think you should know is that if you have a commercial application, want to use a large language model, and don't want to leverage on a third-party API, there are many. Dolly might be a starting point for you. It does not perform the same as, let's say, ChatGPT, unless you do your fine-tuning with your data. So today we're not going to do any of that. I'm just going to show how it performs out of the box. But just know that there are techniques and there are a lot of resources out there for you to use your own data to fine-tune your task and get, you can actually squeeze very decent performance in terms of quality of the output from this particular model. If you want to know more, please ping me. Again, join the Discord, ask on that particular Discord, which should be published on the meetup page, and if not, I will publish it in a minute. What do we need? So we need all the requirements that are described in this repository, which is the OpenVINO Notebooks repository. Particularly, we are running in a Docker provider. So know that building this Docker image takes a lot of time, about an hour or so. I have the image pre-baked if you want to copy it after the workshop, but it's 30 gigs, 30 gigabytes with everything in it. Why? Because I committed all the data after downloading it, so that the workshop runs faster, and we don't need to wait for internet gods to let us get all the bits that we need. So for that, for this particular model, apart from all the requirements that we need to run all the OpenVINO notebooks from that repo, we also need the Hugging Face Optimum library, which I just explained. It's a library that provides the extensions. In particular, today, the part that we're going to be using is the part that allows us to run OpenVINO models in an accelerated fashion, depending on the hardware that we have available. And then this is how basically the changes that you need to do to use this particular library. And I'm going to start running the notebook. First of all, I just want to show you that we have 3 devices. Yes? Okay, so this notebook is running in that machine that says Alpaca. Okay? And you can access it from your computer if you are on Python, and go to alpaca.local:8888. Sorry for not having that up there before. So if you're connected to the network, you can join. If you prefer to pay attention, I suggest that you see what I'm doing and ask me questions, and then you can play with it. If you come to Hacker Dojo, these 2 machines are provided by Intel for you, the community, to come and play with them and learn OpenVINO. I work out of here, so if you want to ask me questions, you can ask me questions, and you can join the Discord to come, play, and not necessarily suffer installing all the huge dependencies in your machine. You can just come here, play, do, and particularly join a challenge that I forgot to mention in the beginning. I'm going to be publishing a challenge this week so that you can win a brand new Intel GPU. On the last workshop, I didn't publish a challenge. I'm going to publish it today because it's way more straightforward with what I'm going to show you today. So again, we're running on one of those brand new Intel NUCs. It's a 12th gen processor, and it has a discrete GPU in it. And that's why we see 3 devices that OpenVINO immediately detects. It sees the CPU. This is, we can see that GPU 0 is the integrated GPU. So this one is a very small GPU, very slow. It's actually going to have worse performance than the CPU. And we're going to have GPU 1, which is the discrete GPU. And it's the one that normally we would be wanting to use for inferencing. However, this particular model runs faster in CPU than it does in GPU. I don't know why, and I'm planning to ask our partners at Intel why that reason, what is the reason behind that. But if you run a model like Stable Diffusion, for example, it runs like 3 times faster, and Victor's going to be showing that between one notebook and the other, so that you see how it can run. So yeah, we have the 3 devices, and we're going to be basically using 2. GPU.1, which is the discrete GPU, and CPU. So Now we're going to go to the hands-on parts. And I'm going to start here. If you run this for the first time, you're going to see that your notebook starts downloading a bunch of stuff, a bunch of JSON configuration files, weights, and then a large binary, which is the pre-trained model. On this particular image, I already have all that information here. And so we don't have to wait for that to download. However, every time we load it, a compilation process needs to happen so that we are ready to use the model for inference. And that's what's happening now. It takes a few seconds. And after that's done, we are ready to perform inference actually I made a mistake here, in whatever device that we decide that we want to run. I'm gonna actually restart because I want to run on CPU. And okay. Oops. Did anyone log in to alpaca.local? No. Okay. I don't know why this thing is not responding to me. I'm just gonna restart my Docker. Give me a few seconds. I'm sorry for the mishaps. It usually happens on the demos. I can't reach the device. Oh. I'm sorry? Sorry, I overloaded our server. Let's see if I can make it work. While this reacts, I'm going to show you the code. So basically what it does, the path that I'm going to follow is it's going to load the pre-trained model here. And I know why that happened. It's because I'm running the two models at the same time. And I should have not done that. And then how these models actually work. And let's pay a little bit of attention here, because it doesn't matter which LLM you're using. All of them work in the same fashion. These are iterative models. And do you know how they are trained? Do any of you have investigated? Well, they are pre-trained in a semi-supervised fashion. What does that mean? Contrary to how we train a classification model, that we provide a set of inputs and a known output, in a semi-supervised fashion, we only have inputs, and then we decide what the output is going to look like. And so basically, there are two ways where you can pre-train a model. One is called masked, and the other one is called causal. Usually, you pre-train with masked and fine-tuned with causal or the other way around, depending on the task. And what that means is we take a large corpus of text, let's say the whole internet, and then we chunk that into little pieces of text and feed that into the model, but remove the last word. And so the task of the model is to predict the word that's missing. And it will try to learn by trying over and over and over again what the most probable next word is. And that's all it does. So when you go to ChatGPT and start asking questions about the meaning of life, it's only telling you what's most likely to be found on the internet, according to its pre-trained dataset. Now, how is this useful? In that process of predicting the next word, these models actually learn the meaning of the context. And what that means is learn the meaning, the actual meaning of the language that precedes the word that we want to predict, right? And we know that a single word in a different position can change the meaning of a particular sentence. A comma, a period, all of those things can actually be very sensitive to the meaning of the sentence. So that's what the model actually learns. It learns to know what the intent of the previous context is, so that it is able to predict with fairly reasonable accuracy what the next word is. In that process, and depending on the corpus that you feed to the model, your model can learn to do interesting stuff like coding, which is, these kind of models are very good at code completion. Why? Because writing code is a very deterministic process. It's very easy to know what's next because the language is very limited. The set of words that we are allowed to use is very limited. And then the meaning is intrinsic to the names of the variables and functions and classes and objects that we assign. So training these models in large corpuses of code is a very good way to get a good result. So the two kinds of pre-training that we can do is causal and masked, and the difference is which word is the model trying to predict. I can give it a sentence and have it predict the next word, or I can give it a sentence, remove one of the words in the middle, mask it, and then have it predict that particular word. And those are the two differences. The reason why we're using a causal LM is that a causal LM is used for text generation and not necessarily completion or correction, okay? So the task that we're gonna be using, which is called instruction following, is pre-trained, is usually leveraging a model that's being pre-trained on causal LM. Was that clear? Because I see your faces like, more or less. Well, I hope it is clear. If not, reach out to me. I can try to explain that a little bit. Then there are a couple of parameters that we can fine-tune, and this is again agnostic for what LLM you're working with. And those are which are the highest probability that we're going to limit our model to select words from when it's predicting the next one. And the other one is something called temperature. And that basically means how creative we want our prediction to be. And what temperature does, it literally opens the window from the most probable word to the set of the top X probable words. And the temperature is basically how likely it is to select a word that's not the most probable one. Because we're trying to do an instruction following task, we will be like turning all of those parameters low so that we get the most deterministic response possible. So let me see if this came back to life. Please allow me a couple of seconds. Okay. Okay, it should be working now. Let's see. Where are we? Yeah. Okay. So we import a bunch of our dependencies. Most importantly, I'm just gonna skim through the code and I'm gonna run it because what I want to do is actually I want to show you how it works. Yes. Sorry, I didn't see your hand.
How do I see that?
Yes. So if you go there. You need to be connected to the local network, to the Python network. If you don't know how to join that network, you can ask Victor, who is around there. And then what I will ask you is, let me run the demo first, and then you can play with it, because we're gonna overload the little machine. Okay, so how it works is the input that we're going to provide to the model, we're going to call that a prompt, okay? And I'm sure you've heard the prompt engineering word. And what does that mean? Well, that basically means how do we design a language that we can pass as input to the model and provide us a deterministic answer that's most aligned with what we want to extract from the model. In other words, you need to learn how to talk to it. Just as how you learn how to search in Google and how to summarize articles from Wikipedia, we need to learn how to talk to each of these models. And each model behaves a little bit different. And so we'll learn how this goes. In particular, if you look at this cell here, cell number 5, you'll see a couple of interesting stuff. There's an instruction key, which is this token. That's like number, instruction. Is that better? Or like that? Okay. So we have this pound instruction. Then we have this response key, pound response, and end key, pound end. These are special sequences that we are selecting so that the tokenizer knows that they become a single token. That mean this is the beginning of the instruction. This is the beginning of your response, and this is the end of your response. Why do we need an end token? Because if you look at the cycle here, there is no exit condition. So the model needs to tell us, I'm done, right? And by the way it does that is by outputting this end token. Is that clear? More or less? Don't worry, you're gonna see it more clearly in a few minutes. And then we just defined a few helper functions, which is configuring these tokenizers, how they work, getting the IDs. This run generation function, which is the one that actually runs inference, and we're gonna look into it in the second notebook with more detail, and then a couple of helper functions that allows us to run this very nice demo here. Okay, so should be opening. Let me see if I can open it here. The demo gods, they don't like me. Okay. Here we have, so if you see, this is actually running from the notebook. What do we have here? We have a very nice user interface that was created with these very few lines of codes. Very few lines of code. Here. Using an awesome library called Gradio. If you don't know it, you should, because it's the fastest way to build a decent looking UI for data-oriented application. So check it out.
Can you spell?
Gradio, it's GRADIO.app, and it's this. Yeah, you basically do this, and it does magic. Great for prototyping, not necessarily great to deploy something to production, but if you want to test something, if you want to have your users give you some input, it's a great resource to it. And particularly, we created this model here. Now, all these parameters that I mentioned before, we can modulate them here. How many new tokens we want the model to generate? You don't want it to run forever. What's the top? Nucleus sampling basically means the sum of all the probabilities of the top most probable words. Like you basically filter until you have this number here, which is 0.92, which to my taste is a little bit too high, so I'm gonna bring it down. Top K is in case you want to randomize a little bit or limit how many words you want the model to sample from the logits. This is it. It's an integer, and then the temperature, which is how fun you want your model to be, right? So we have some predefined prompts here, and I'm gonna just click submit here, and now it's running. And now to demonstrate that it's actually running, so you can see how the model starts generating tokens, and we have some performance metrics here. It generates 7 tokens, 8 tokens per second on CPU, which is, I would say, pretty decent, considering the hardware that we have. Yes?
What kind of CPU?
So this is Intel 12th Gen CPU.
Is it like i7 or i5?
It's an i7. Okay, how do I oh, this is we can see the CPU here. It's a 12th gen. This is the model. Core i7 12700H. Okay. OpenVINO is particularly well optimized for that generation. And if you there's a quantum leap between 11th gen and 12th gen. So if you have access to a neural processor, I recommend you try that. So now the generation is done, and this is our recipe to make some pizza with pineapple, right? I don't know. I don't know if it's good or not. I don't know if I could try it. But well, we have a bunch of examples that have been provided by the fine people at Intel here. But we can ask whatever we want, like, what is the meaning of life? And we can make it spicy and see what it thinks, right? Yeah, and that's gibberish. Yes.
The training data set. If I go back to your notebook, then where is the training data set?
There's no training data here. So if you want to learn how this model was trained, you need to go to their GitHub repository, because they explain it here. And they use this Databricks Dolly 15K dataset, which is 15,000 short form instruction dataset that was manually created by the Databricks employees.
What's the data?
Databricks Labs, Dolly. If you search for Dolly D2, you're gonna find it, and you're gonna find like a bunch of blog posts and articles explaining how this model was actually trained, how you can use it, what makes it special, why it's awesome that it's commercially permissive, and also what you need to be careful with. So
you just downloaded this Git repository, and that's a trained one.
Actually, the model was not downloaded from that repository. It was downloaded from Hugging Face. So Hugging Face is where all these models are hosted, and with this very simple line, from pre-trained, and then I pass this path.
How do you spell Hugging Face?
Hugging Face so Hugging Face is this emoji, you know, the one that wants to hug you. That's the name of the company, Hugging Face. But this is an awesome hub that has every model known to man pre-trained and available for download with just a single line of code from your notebook.
Going back to your source code, what is the one line? Can you enlighten?
Yes. Is that better?
OV model. How do you download it? OV model.
So this line here, the first time you run it, actually this one here, it will automatically go to Hugging Face, get the configurations, get the weights, download it, do some magic for you, make it ready for inference, and you can save it locally, which is whatever. You can try it at home. It's like 10 gigs, so it takes a while. That's why I have it pre-downloaded. So if we come back to the example here, we can see that if we dial up the temperature, it makes no sense, right? So that's something that's useful to know. And if we try to make it more deterministic, so this is the most probable answer that we will find in the internet if we averaged this question, right? So again, how is this Databricks Dolly 2 model pre-trained? It's using the pile, which is a corpus containing open source data sets that are mostly benign. And I say mostly because these data sets are so massive that it's impossible for a person to actually go through all the entries and make sure that there's no biased content, improper content or whatever. But it's mostly benign. And then it's fine-tuned with the Databricks Dolly 15K, which is the short form instruction, so that it's trained to the instruction following task, which is the task that we are running here. We give it an instruction. Tell me the meaning of life. And it generates what it thinks the meaning of life is. And so you can come here and make it do some interesting stuff. So this is one of the things that you can do. But this is not really useful in real life, right? So what could be, for example, useful? Well, if we say, translate this JSON object to YAML, and then we provide a JSON object that says name, Jose, location, mountain view. Okay, let's see if that works. It actually worked. It's a super simple YAML, but it's actually YAML. How can we make it more spicy? Let's say oops. So that we see that it's actually YAML. Let's say car, computer, right? And I'm gonna do this, another object, and it's gonna be a brand. My computer is an Apple. And then we're gonna say RAM. I'm gonna say this has 16 gigs. Okay. So it's not correctly indented because the UI is removing that, but the output is actually correct. Okay. We could change that, like, for example, instead of making it an object, if we make it a list, like that. Okay. What can I tell you about working with prompts? Try to be as expressive in as few words as possible. Try to not be ambiguous in what you're asking the model to do for you, or if what you want is a deterministic response, unless what you want is actually creative writing or whatever. And finally, try to use correct grammar and spelling. That actually helps. So yeah, that would be the end of the first demo. This is the demo provided by Intel. And this is the first task, which is instruction follow. Do you have any questions about this particular task? Yes.
I'm kind of new to this field. Could you please explain like what is it Intel OpenVINO is?
Yes. So OpenVINO is a toolkit provided by Intel that allows you to run machine learning models in any hardware device um, without you having to do a lot of code. It's kind of magic how it optimizes the model so it runs as fast as it can run. And when I say as fast as it can run, I really mean it. On different devices like CPU, GPU, and FPGAs or any Intel devices that you might have. So for example, here I have devices, and we saw that if we run on CPU, this particular task was averaging 4.49 tokens per second. If we move to GPU, it takes a while to move all these 10 gigabytes of weights from one memory space to the one that's accessible by the GPU. So let's give it a little bit of time for that. But you can see a difference in performance. And the only thing that's happening there in code is this variable that says device. Where is it? Select device. It's changing a string from saying CPU to saying GPU.1. That's all it does. Okay, we should have it soon. Yes?
So I tried the website over there and I couldn't.
Why not? Are you connected to Python? Yeah, you need to be connected to Python. Yeah, if you're on Hacker Dojo network, you won't be able to reach it. You need to be connected to the Python network, which is a special Wi-Fi network set up for this workshop. Yes?
So you are running this model on a consumer-grade CPU, right?
In that CPU right there. If you want to go and touch it, you can feel how it
So
is called.
if I have a laptop for $1,000, I will have the same CPU.
You will have the same what?
If I can get a laptop with similar CPU for $1,000.
Yes.
So my question is, there could be other Python libraries that have been optimized for consumer-grade GPU,
Correct.
right? And they will produce the similar results.
Yes.
So as a website developer, I have two options: using this model or another model that has been optimized for GPU and it still costs me the same price.
Correct.
What are those?
It depends on what hardware you have. Now, usually you won't be running, if you're providing a service, you won't be running that model locally. You'll be running it in a virtual server somewhere.
So it's an AWS.
In AWS, right? If you check the costs of running a container with GPU and without GPU, with the same amount of memory, it's like 100 times difference.
100 times cheaper running on CPU.
Yeah, I mean, it depends, but yes. So that's a huge advantage. Now, does it run faster in CPU than GPU? No, not necessarily. It depends on the level of optimization that you can achieve with each and every particular architecture. Right? So there's not a right answer that always works. But OpenVINO, in my experience, actually gives you a viable way of scaling a machine learning application in production.
So you're connected with OpenVINO and Intel support for OpenVINO.
Yes.
And what is their commitment for the next version of Intel 14th or 14th?
For that, I invite you to visit. So those kinds of questions, I believe you can come here to OpenVINO Toolkit OpenVINO and file an issue and ask those questions. And also the docs at OpenVINO, they have a lot of information about what OpenVINO actually is, how it works. It's important for you to know that it's open source. It's been around for several years. And as far as I know, it's going to be around for many years.
So are you saying
ahead
it
of
has
us.
been recommended by Intel or it has been endorsed by Intel?
No, this is made by Intel.
Right.
Made by Intel.
Are
Yes.
there other libraries that are also made by Intel?
There are several libraries that are also made by Intel. One of them is OpenVINO. The other one is the network neural compressor that I was talking about in the beginning, which is a separate library, but it's part of the same machine learning ecosystem that Intel's.
And then comparing this library running on Intel and AMD or other processors.
Yes,
Performance?
it will perform better on Intel. It works on any x86 processor, as far as I know. It even works on my M1 Mac. Sometimes. The Apple Silicon support is experimental, and you can, if you go to the repo, it says like Apple Silicon support is experimental, but it works most of the time. And again, is it the right answer for everything? No. If you need like real-time response, maybe you need a GPU, right? But if you need something that can scale elastically, for example, without you having to dig too much into your pockets to pay for the extra GPU servers that you have to spin off, then it's a great library.
So I cannot use it for chatting server because the response is slower. It's taking longer for a chat.
Yeah, it's gonna take longer. And again, if you want, we can dive deep into this after the workshop, so that we continue with the content. I have another demo that I would like you to see, and I'll be happy to answer all your questions after. Okay. Any other questions before we move on? No. Okay. So now, the second demo that I want to show you, it's a different task, which is we're gonna be using. So one of the questions is, okay, so that model is answering my questions and my requests based on the data that it was trained on. But what if I wanted to ask questions regarding my data, right? I have a corpus of, I don't know, maybe I'm a corporation with 2,000 different products, and I have all those 2,000 user manuals digitized somewhere. I'd like to, just know which page I need to go for a particular issue. Well, that task is called retrieval, and that's what I'm going to show you today. We're going to be using a couple other libraries as well to help us. So just as I said that Hugging Face is an abstraction layer on top of OpenVINO. So OpenVINO operates on a very low level. On top of that, we have abstraction layers like Hugging Face that makes it programmer friendly, developer friendly. Now, on top of that, there are some libraries that are specializing in language. One of those libraries that I like a lot, it's called LangChain. It's open source, it's Apache 2, you can use it for commercial purposes or for research or for whatever you want. Another one, another resource that I'm using is called FAIS, which is the Facebook AI Similarity Search. This is a library that allows you to find vectors. Do you remember when I told you that when you input a sequence into a model, it converts that into a vector that represents the meaning of the sequence, right? That particular vector is called an embedding. That's how we call it in the industry. It's just a vector, a set of numbers that has some meaning to that particular model. How is that useful? Well, being a vector, it means that we can do algebra with that particular vector. So FAIS is a library, open source, again, by Facebook, by Meta. I think it was open source something like 5 or 6 years ago. But right now it's taking like, again, it's like vigorously being developed because of this hype around LLMs. And I find it particularly easy to work with for prototyping, and that's why I chose it to show it here. It's not the only one. You can use some other libraries called, one that I also like is called Chroma, for example. And there are like 20 different ones. Even if you don't want to host your own database, the largest offering that I'm aware of is called Pinecone, where you can actually access a hosted instance of your vector database and perform all the algebra on someone else's hardware and just pay for the service. All of that is very well documented in LangChain. I suggest you to go visit LangChain. These are the docs. Again, it's open source, and they have a bunch of modules. And today we're going to be working with a particular model called text embeddings module, which is, instead of having the model predict the next word, we only wanted to know, give me the vector that encodes the meaning for you, right? So I give you a sentence, you give me a vector. And we're going to do that for a large corpus of documents. Well, large. So this is our new prompt. Our new prompt is, below is an instruction that describes a task. Be as helpful and concise as possible. Very similar prompt. We didn't do a lot more. And this is how it looks, right? It's just text. It's plain text. But remember, we have this special token, and whatever we write as an instruction will replace this instruction in between those mustaches. Okay, so we load the same model. This is, let me just come back here and make sure that we're freeing the memory. Okay, before we load it, and then we load the model here. And we're going to be loading two different models. The first model is going to be the text generation model, and the second model is going to be the embeddings model. Now, we use the same code that we were using for generating tokens, but now I'm actually going to stop and show you what I'm actually doing. You get some instruction from the user, and then we format that prompt. What this line does is literally takes this text here and replaces this with the instruction that I injected to the function. Okay? And then we have the inputs, and that is the prompt text after running it through the tokenizer. Now, if you remember what the tokenizer does, is it splits words, it splits my text string into smaller chunks, and then replaces that with numbers, because machine learning works with numbers and not with characters, right? So that's basically a translation between a human readable thing to a model understandable thing, but it's the same thing. No other transformation has happened here. And then we have this particular class that's called text iterator streamer that we run on a separate thread and provide it with these new tokens and all the parameters that we set from the interface, like how many new tokens we wanted to produce, what's the top P, what's the temperature, what's top K, etc., etc., etc. Okay, so we do that, and then we start pulling out the results. So what does it actually do? Let's ask this very deep question. What is good about being a cat, right? And so you see what I was telling you. It just produces one word at a time, and this is the speed that it does it at, right? So it's slowish. But again, consider the hardware that we're running in. I think it's quite impressive. And it actually makes sense, right? What it says. Being cat apparently is great. Now the next part that I want to show you is we need data, right? So I cannot share my corporate documents, but there are a bunch of public data sets that you can use to play with. In particular, I went to Kaggle, which is this website for machine learning enthusiasts. I think it's backed by Google. And they have, if you go to the landing page, they have a section called datasets. And you can find a lot of public datasets here. The one in particular that I'm using today is called Wikipedia Movie Plots, which is basically you click download here and you can download, and what you're gonna get is this comma-separated values file with the year, the title of the movie, where it comes from, who's the director, who's the cast, etc., etc., etc. And then the interesting part is you actually have a blurb for the plot, what the movie is actually about. So that's what we're going to be working with. How do we do that? Well, we import this awesome library called Pandas that allows us to manipulate objects called data frames. And we, in a single line, read that Excel, load it into memory, and we can see that we have almost 35,000 different movies, okay? And each of those movies has that and those columns. And then if we look at what the text actually looks like, so this is the description that we got from that data set, right? So it's a short description. It's good enough to experiment and play and do stuff with it. Next thing we're gonna do is we're gonna import two things. We're going to import, actually, the second one I don't think we need it. We're going to import the LangChain abstraction for FICE. Okay, so basically we're going to run this vector database locally. And then we're going to do a couple helper functions, get pipeline and inference functions, that the first one just returns a pipeline. Now, if we look at the task, this is a different task. This is not text generation, this is feature extraction. Because the actual task that we want out of the model is not text generation, it's the embedding. And then we pass the embeddings model and the embeddings tokenizer. Those are going to actually be defined here. For reasons of time and being able to do this in real time in front of you, I'm selecting a very small embeddings model that can run very fast. But there is actually a way to do this using the model that we were using for text generation, which is Dolly. The only thing that you need to do is put the same values here as we have here. Okay? You just do that, and that's all you need to do. So we do that, this already went to Hugging Face, downloaded the weights, compiled the model, and it's a very, very small model. Not very high quality embeddings, so our search is going to be a little funny, but it's going to work. It's going to demonstrate that it actually works. How do you get better quality results? You use better quality embeddings. What does that mean? You use an embeddings model like the one that we were using for Dolly 2. And I can demonstrate that in the end, what you need to do to change. But I want you to actually see this. Then we define this very simple class to process the inference, create an instance of that, and convert all our documents into, so what we did here in this line is we converted each row into these objects called document schemas. The documents have one very important field, which is page content. And that is, we fill that with the plot that we have from the dataset. And the other one is called metadata. And the metadata, we're going to put some of the columns that came from the dataset. Some of them are empty, some of them are actually there. It doesn't matter. And then what we're going to do is we're going to create an instance, and this is going to take a couple of minutes for the embeddings. So what this is actually doing is iterating throughout all our 35,000 documents, extracting the text from the plot, running inference on the model, getting the result, and storing it in this structure that will be friendly for us to do search over. Okay? So, in other words, we're using the same mechanism that we were using to answer questions, but this time we're going to be finding information from the data that we're providing. Okay. So I don't know. I can think of a girl named Rose is in a ship that sinks, and see if it finds the Titanic. Right. Okay, let's just be a little bit patient with this. It's going there. It's not fully using the CPUs, and I have a theory that this might be, we might be able to optimize this further, but I'm not doing anything fancy today. While this runs, do you have any questions of this particular task? Comments? Complaints? No? Are you learning something? Yes? No? Okay. Okay. So no, it didn't find the Titanic. Let's see. Lion should be king, but runs away. Okay. It's here. It's one of the results. The Lion King, right? So I don't know if you see that, but now the awesome thing about this is I actually accessed the record that I wanted to access, and I can provide some search results immediately. Like, it takes no time to go retrieve the document that I have, and I have my original document in here. Oops. Here, right? I don't know, I find it particularly useful. I'm already doing this in more than 4 places in production since I learned how to do it. Yes?
So I have a question. If do this search for many times, we can get exactly the answer?
If you search?
Yeah, more times.
Yeah, I mean, if you provide, so let's cheat a little bit, okay? if results I'm gonna cheat and I'm gonna do this and I'm gonna search this particular sentence here. And so now are the top results. Why are these results not perfect? Because the embeddings are very small and very low quality. And I'm doing a trick to make it faster, which is that I'm only embedding the first 100 tokens from the description. So maybe the thing that you're searching for was later in the description, but I just didn't include it in the okay? Again, I'm trying to show it, to show it working, right? But see how little code I needed to write so that you can create something that runs on consumer hardware and finds the answer that you're looking for in a corpus of documents. I think this is super powerful to enrich your applications. And then let's combine the other one. We can do, we can convert this result, right, into a JSON string that we're going to call context, and we can actually change the instruction. Write the text for a funny tweet about this movie, okay? So if we format it, we say The Lion King, directed by this guy. Let's say, no, cast. And we provide the plot and ask our other model, hey, can you generate a tweet for me? And let's see what it does. And let's see what funny means to Dolly V2. Okay, it's not very concise, doesn't look like a tweet, and it's not funny, but it's doing something. This is where you can start experimenting with this prompt engineering. I think I'm providing too much plot and too little. Let's see what happens if I for example remove this. And just work with that. So this was the tweet, which doesn't look like a tweet at all. It's more like a summary of the plot, right? Maybe it doesn't know what a tweet is. But this is where the fine-tuning comes into play. If you go to the Databricks Dolly 2 repository, they actually provide you with instructions and examples of how to train on your own data. So you can train this, save your weights, and use all this infrastructure to actually run inference on your particular task. And I think that's awesome. Again, it just gave me what it knew about the movie without providing it any of the context, right? So now I'm digging into the language model knowledge from the pre-trained data. Okay, so you can play with that. For me, a particular useful application task is retrieval, just retrieval. And then once you retrieve your documents, you can do a lot of stuff with it. So those are my examples. I don't know if you have any questions, comments, complaints, or any other thing. Yes?
You said all these can be accessed from Discord.
Yes, so if you join the Discord, I will let me open the Discord. So, yeah, Open Vino workshops. So it is this, and then copy link. I'm just gonna write it here. I don't know where to publish it. I'm gonna publish it in the meetup event. But yeah, if you join the Discord, I can give you like the instructions how to pull or create the Docker image yourself, or you can come and work on those machines whenever you want. You just say, hey, I'm here to work on the OpenVINO notebooks. And yeah, that's what they're for. And then if you follow the challenge, so what the challenge will be is to actually select another data set and perform a summarization task that provides, that extracts what's called like name entity recognition, which is I'm gonna point you to a data set and I'm gonna ask you to write a prompt that creates a JSON with some specific information found on every record of that particular thing. So that's gonna be the challenge. I'm gonna give you the details of what data set and what JSON schema I want and what the text test criteria will be and how to submit on the Discord channel. So please join the Discord. There. And I think the Discord is already on the description. It should be, it is not. Okay. Well, it's here. Just join, ask me questions, and let's have fun with machine learning. That's all from me. Questions, complaints, comments, welcome. Thanks for joining. See you in a couple of weeks for the next one. The next one is going to be vision again, and we're going to be working with object detectors. Thank you.